Hello, Mr. Blackwood. I'm Alex Potter, and I'm here to talk to you about quality control of aggregate material within Aberfoyle sand and gravel pit. For my presentation, I will be talking to you about the importance of building materials, a little history of St. Mary's and CBM aggregates, some background about Aberfoyle, McNally, and David sites, some of the major products produced, the hydrology and rehabilitation process. Also, we'll be talking to you about the processing of the aggregates, the quality control of concrete, asphalt, and foundation, and the quality control issues that come along with them. We will be talking about 19 mil concrete stone, concrete sand, granular A and B, and then I will follow up with my conclusion, recommendations, and for you to ask any questions. The importance of building materials. Building materials such as concrete, asphalt, and foundation are seen on almost every construction site around the world. Foundation material like granular A and B are usually intended for subbase within the pavement structure and backfill for construction projects. The foundation is used to establish solid and secure ground before erection of construction projects. Asphalt is the main component of the world's roadway system. It is laid on top of the foundation to create a surface that can temporarily withstand heavy pressures and harsh weather conditions. Concrete is a building material that is heavy and structurally sound to create and form a building or structure. This building material has been one of the most important to the world since it has erected long-lasting construction projects. St. Mary's Cement Group. St. Mary's Cement Group was founded in 1912 by John Lind and Alfred Rogers. The company is able to produce over millions of metric tons of material annually and helps to provide for Canadian and U.S. customers. Some of the projects St. Mary's Cement Group are best recognized for are the CN Tower, Maple Leaf Gardens, and the Roy Thompson Hall. CBM Aggregates. CBM Aggregates is a part of the St. Mary's Cement Group operation by producing over 140 million tons of aggregates annually for ready-mix trucks and construction sites. There are over 450 ready-mix trucks provided by CBM that delivers mixing machines that have made-to-order product that is usually time-sensitive. The construction sites may use the product for concrete, asphalt, and foundation. St. Mary's CBM has 12 sand and gravel operations and quarries that are in operation year-round. Aberfoyle site. For my co-op, I worked out of the Aberfoyle pit. It is 300 plus acres and has been in operation since the 1950s and is considered the main site for CBM aggregates production in Ontario. The Aberfoyle operation is well monitored and has great production of the various building materials. This site has 3 front-end loaders for the material movement and 4 material conveyor belts with smaller conveyor belts for separation of material. This allows for a large quantity of transportation truck traffic and building material production. Aberfoyle Sand and Gravel Pit produces a variance of materials from coarse concrete stone to fine concrete sand. The McNally site. Located across the road from Aberfoyle Pit, it is also operated by the Aberfoyle management and is sometimes considered Aberfoyle South. The McNally pit creates material for concrete and asphalt like Aberfoyle, however creates material more acceptable for asphalt elements. This operation creates HL8 for coarse stone products and HL3 material for asphalt density. McNally pit creates approximately 10 different products that vary from concrete aggregates to asphalt material. The David site. The David pit is operational in Cambridge, Ontario. The David site is also only a short distance from Aberfoyle, and therefore the testing of material quality is completed by Aberfoyle's quality control. The David Operations is a large producer of granular A and granular B. The David pit has one of the newest material shakers and is highly efficient when producing material for low moisture content. On average, a regular material shaker will have 24% moisture content, whereas David site's new material shaker will have 6% moisture content, saving a lot of material for being washed away. The major products. CBM has numerous products available including concrete, crushed stone, round stone, and sand products. Each product is used for our ready-mix trucks that use different techniques of maximizing concrete. Maximizers like the shrink guard reduce cracking and shrinking with CBM ready-mix products. Most sites are able to produce the most common products like 19 mil concrete stone and concrete sand. The hydrology and environmental process. The Aberfoyle plant has been known for its hydrology and environmental process. The Aberfoyle plant works in a cycle starting with the lake, which is used as the Aberfoyle plant's only water supply by washing the material that is placed in the material shaker and separator. After the material is washed with the lake water, the water is then drained back into the ground for filtration and circulated back into the lake to be recycled. The quality control technician sieves the recycled water periodically from the plant to examine how much material is being lost from the manufacturing process. After a period of time to allow for material to settle, the lost material is recycled into the plant and restored for production use. The water that is recycled is clean and great for wildlife due to the filtration of sand and gravel throughout the Aberfoyle site. The water that is coming from the plant may look dirty, however, after settlement of the sedimentation, the water is clean and can support various wildlife. Rehabilitation. Since the Aberfoyle pit has been in operation since the 1950s, the natural state of the grounds has been progressively rehabilitated. Over 30 hectares have been rehabilitated to support new agriculture, naturalized areas, ponds and aquatic wildlife, and a green environment. Rehabilitation of the Aberfoyle site has included land shaping, wetland and shoreland creation, seeding, aquamats, breeding grounds, and protected cover, and also ongoing tree planting. This is a before and after of rehabilitation of a sand and gravel pit which has produced materials for Ontario for many years. This advancing rehabilitation process in the Aberfoyle sand and gravel pit has thriving wildlife and environmental structure that is returning the land back to its natural state. Aberfoyle Sand and Gravel Pit has achieved an award of excellence for the cooperation of environmental and business success within the Aberfoyle location. Processing of materials. Processing of materials in CBM aggregates begins with raw materials. The raw materials include large and small stones, gravel, sand, and clay. The clay will be mostly disposed of through washing. The raw materials are mined and produced through quarries and the use of the skyline dredging crane, which is used to reveal raw materials that is then transported with conveyor belts and trucks to the Aberfoyle location. The excavation process for Aberfoyle's site was once a pit that excavated material from their own site. Now it is mainly a middle ground for transporting raw material from nearby locations and manufacturing building materials to transport. The Aberfoyle site is a multi-source excavation process. The crusher. The crusher is the most important equipment for processing raw material. The raw material is placed in the equipment which crushes large material into smaller material. Large material enters the crusher, then passes a rotating drum which then crushes the material into smaller material, then into the sieves for separation. After the material has been crushed, it is brought to the sieve screens that will determine what size material goes where on the conveyor belts. They use plastic sieves that are removable just in case one section breaks, it is easily replaced and production continues. These sieve screens allow the plant machinery to create a certain type of building material that requires established building standards. After the sieves sort the material, the more fine material needs to be washed of clay and have an accepted moisture content in order to satisfy specifications. Following the conveyor belts is the washed and processed material that creates stockpiles of predetermined building material. These stockpiles are usually 15 meters tall and have a 2-to-1 slope to create cone-like stockpiles. Finally, these manufactured products are tested by quality control to ensure high-caliber products are being constructed to specifications and building standards. Quality control at CBM aggregates. Quality control in CBM aggregates is very important to ensure customer satisfaction and high-quality building material that is reliable and trustworthy. If the products used to create a concrete mix is not right by the ratio of coarse and fine aggregates, then the structural stability of the concrete product can be spoiled and therefore rejected as a building material. Quality control in Aberfoyle Sand and Gravel Pit obtains the highest level by monitoring all products manufactured in 3 different plants. In order to have products for quality control testing for the day, CBM aggregates must sample every product from each plant location. The day begins by collecting samples in the early morning from the night shift production. A quality control technician or engineer will extract the appropriate size samples from stockpiles that were produced recently. For safety and randomized testing, sample pads of material are dug out 90 degrees of the stockpile. This is to ensure segregation hasn't occurred and to confirm random sampling of material from the stockpile. Also the safety factor leaving the quality control technician out of harm's way. There is normally 2 stockpiles for each material, a shipping stockpile and a production stockpile. The production stockpile is tested frequently to ensure manufacturing of product is qualified for standards. The shipping stockpile is the material that has been tested by quality control while being produced and has been settling for shipping purposes. This is tested to ensure settlement process has not adjusted the material and caused change in material data. After the samples have been extracted from the stockpiles, they are returned to the quality control lab where the material is split again into smaller samples to ensure true randomization and not to segregate material. Each product is oven dried, washed, and then oven dried again for moisture content. After being washed and weighed, the material is put through a sieve analysis and recorded into a computer database where the contents measured are evaluated. The computer database displays if the material is within customer satisfaction and building material standards. At CBM Aggregates, the computer database has two specifications. There is the CBM Aggregates target and the building standard specifications. The CBM Aggregates target is more narrow in the amount of error within the products. A building material can be within specifications, however out of CBM building material targets. If material is too fine or coarse, a red flag and an email will be sent to management for further evaluation and product problem resolution. This format of quality control allows for little mistakes and punctual resolution for problem solving. Concrete aggregates. CBM Aggregates manufactures numerous products used in concrete infrastructure. The concrete products that are manufactured are concrete stone, crushed stone, round stone, and sand. Crushed stone is different from concrete stone due to the fact that concrete stone has rounded edges more like found in nature, whereas crushed stones are sharp and jagged formed from the crusher. The crushed stone is used for interlocking, binding, and strengthening of concrete, however can cause a problem with easy flow from ready-mix trucks and mixing machines. Concrete stone and crushed stone are combined together to create a 19 mil concrete stone with respect to the ratios for concrete mixes. The concrete stone and sand are the main components for a proper concrete mix aside from cement mix and water to bind everything together. Asphalt aggregates. CBM Aggregates also produces asphalt material. Most popular is the HL3 product, also known as asphalt stone. The HL3 asphalt stone is used for common roadway surfaces, parking lots, and airport runways. Foundation aggregates. Not every location in CBM Aggregates produces fill and foundation because there are only some plants that can retrieve the material to manufacture the product. Granule A and B are the fill and foundation products that CBM Aggregate produces. These materials are developed through recycling of old materials such as sand, gravel, and concrete, and are fabricated for a compaction base. These products are a base layer for pavement structure, granular shouldering, and backfill. Quality control issues. Issues arise in quality control just like in any other profession. Different material is loaded into the various treatment plants within CBM aggregates and therefore cause different outcomes in material data. Every machine that works in the processing of material has functional delays and malfunctions. Quality control also faces daily human and electronic errors within the lab, and those problems must be faced and resolved before material and specifications are permanently damaged. These errors can be shown through 19 mil concrete stone, concrete sand, and granular A and B. Quality control issues with 19 mil concrete stone. 19 mil concrete stone is one of the major aspects to making concrete. The concrete stone is the large gravel that is the strength and durability of concrete. 19 mil concrete stone has some quality issues that can spoil a shipment of the material. It is crucial that the stone has a good ratio of larger stones to smaller stones within the compound to meet specifications. The particle shape and surface texture of the concrete stone can deeply affect the water and cement ratio content. If the concrete stone is rough textured, angular, and elongated, the concrete mix would require more water and cement to produce a workable concrete. Quality control also has to keep under observation that there is no segregation of the size of stones. If the concrete stone is segregated and in favor of the larger stones, then there will be a decrease in concrete void content, which affects the amount of cement paste required for the concrete mix. Quality control issues with concrete sand. Concrete sand is a key material in the manufacturing of concrete and is the small aggregate that is the strength, hardness, and durability of concrete. Quality control can have many issues that take time and patience with concrete sand due to its sensitive machinery and size of particles. Concrete sand can be very dirty with clay because of raw material that was placed into the refinement plants. Aggregates for concrete need to be cleaned to ensure no residue mixes with the water and cement, which can cause improper bondage and deterioration of concrete. Just like concrete stone, the particle shape and surface texture of the concrete stone can deeply affect the water and cement ratio content. Quality control has the largest variances of problems with concrete sand. This includes monitoring moisture content, cleanliness, and segregation. Quality control issues with granular A and B. To ensure full quality control for granular A and B, two different sieve analyses must be completed for each sample. One sieve analysis for the coarse aggregate and another sieve analysis for the fine aggregates. An issue with the quality control of granular A and B is that when completing the required sieve analysis on the products, some material is lost due to washing, drying, and splitting into workable samples. Granular A and B, when dried, have dust-like qualities within the product. So when transporting and splitting into workable sample sizes, dust and other material particles escape from the overall samples. Even though granular A and B specifications are in large range, the escaping material can cause obscure data within the standards and specifications. Finally, the conclusion. For my conclusion, I would like to bring forward key facts of my presentation. Concrete is known for being one of the strongest building material construction has to work with. It has helped shape our cities and society to what it is today by withstanding time and erosion. Granular A and B are the foundation and backfill for every construction site to make sure the ground level is safe and secure before the vertical erection of structures are formed. Asphalt is the world's transportation system by being the main building material for road surfaces, parking lots, and airport runways. Quality control is regarded to be top priority for infrastructure because of catastrophic failures that can arise if building materials and products are out of specifications. It takes close monitoring and analyzing by quality control technicians and engineers to uphold the highest standards for acceptable products. Issues emerge from unexpected changes and is quality control that uses problem solving and experience to restore order to high quality building materials. My recommendations. In order to complete this, I asked the question, if you could change anything, what would it be? Through the experience of working at CBM Aggregates in the Quality Control Division, the only recommendations are to engage in younger audiences and students. The quality control technicians are experienced adults that have been employed in the construction field their entire careers. Students have limited knowledge of the opportunities that are available for quality control technicians. With the younger audience captivated by the career opportunities, it will induce a larger demand for jobs involved in the quality control of building materials for the construction industry. I thank you for your time, and if you have any questions, please email me at alexander.potter@mohawkcollege.ca.